So the first question here was 8C, and we've got, sorry, one thing, guys, I am not able to record my screen and present and monitor the chat, so I may not see stuff in the chat. Please just unmute and stop me if you have any questions, okay? So for 8C, we've got this kind of combination of vectors A and B. I would simplify before I go and sub in the unit vector form for A and B. So here I'd say that this is 2 times vector A minus 6 times vector B plus 6 times vector A plus 21 times vector B. So that's 8 times vector A plus 15 times vector B. And then I'd take the values for A and B and substitute those in. So 8 times 3, I don't know why they don't have like the hats here, but I'm just going to change it to write them like that. Because whenever we use I, J, and K as our vectors, that really always means those special basis vectors. Plus 3j hat minus k hat. So that would be 24i hat minus 32j hat plus 8k hat minus 30i hat plus 45j hat minus 15k hat. And then negative 6i hat. How many j's? 8 and 5 plus 13j hat. And 8 minus 15 is negative 7k hat. Sorry, that's lagging a little bit on my end. I hope it's showing up okay for you guys. So again, please just unmute, stop me if you have any questions. So this is actually an interesting one. The next example, show that if vector OP is 5, negative 10, negative 10, then the magnitude of OP equals 15. And I think that this is a nice way to kind of take a look at why that magnitude formula works in 3 dimensions like we kind of want it to. So I'm going to very, very roughly draw out where this might be. So this is a value of 5 in the x, negative 10 in the y, and negative 10 in the z. So super roughly here. Like that. So this is kind of this. Anyway, sorry, that's kind of quick and a little bit messy, but this would be this point 5, negative 10, negative 10. And if I wanted to take a look at how far away this is from the origin, so how far away that is, I'm going to call that D. And I'm going to sort of take this off of the kind of XYZ plane and start thinking about this in terms of just a rectangular prism. So I know that this is a rectangular prism and that the lengths here are 10 and 10 and 5. 5 in the X, 10 each in the Y and Z. We're just talking kind of straight distance, not the sign. Doesn't really matter, positive or negative. And what we want to find is this distance here from our point P to the origin. So what we're going to do is really just using Pythagorean theorem twice. So first of all, I'm going to make a point there. And I'm going to just draw here, this triangle in here. I'm going to label that diagonal distance there as x. I know that this would be 10. And I'm just going to redraw this triangle like that. This is 10, and that's 5, and that's x. And this is that blue triangle on the bottom of my rectangular prism. So that's this triangle here. Now I know that we're all okay with saying that x squared is 5 squared plus 10 squared, because that's Pythagorean theorem. Next, I'm going to look at a different triangle. Now I'm going to create this triangle that uses x as one of the sides. So this triangle kind of going up and through the middle. That's my D. This is my x that's on that diagonal on the base of the rectangular prism. And then that's 10. So here I know that D squared is x squared plus 10 squared. And this is how we extend that distance formula, or the magnitude formula, to our 3 dimensions. But I also already knew what x squared was from the flat bottom of my rectangular prism. X squared is 5 squared plus 10 squared. And then I still have another 10 squared. So this is the magnitude of OP, which is going to be the square root of 25 plus 100 plus 100, which is the square root of 225, which is 15. So that's a good thing for you guys to see, to understand where that comes from. Hopefully that kind of 3D magnitude formula makes more sense, having kind of taken a look at it in that form. Okay, the next one, this says the vertices of quadrilateral ABCD. Remember, when you're labeling a quadrilateral, you have to label around in one direction. So you can't like zigzag across. You have to go in the order that those points are connected. And this says, prove that ABCD is a parallelogram. Who can tell me what the criteria is to have a quadrilateral be a parallelogram? I'll flip back. Anybody in the chat? What things do I have to know? Who has a sibling in grade 8? Ask them what a parallelogram is. Good. Matthew, 2 parallel sides. What else? Abby, good. Opposite sides need to be equal. So the opposite sides have to be parallel and the same length. If we're talking about vectors, if they're parallel and the same magnitude, what would that mean about the vectors? If I said, oh, 2 vectors are collinear, would be the parallel. So collinear means scalar multiples, but if they had to also be the same length, the exact same vectors, yeah. Or I suppose opposite if you did like A, B, and C, D. But if vectors are the same vectors, Like if the vectors are equal, then we know that they're parallel because it tells us direction. And we know that they're the same length because it also tells us magnitude. So vectors tell us magnitude and direction are equal if the vectors are equal. So what we really want to prove is that vector AB equals vector DC, and vector, let's say, AD equals BC. If those two things are true, then we know if these vectors are equal and these vectors are equal, then this is a parallelogram. So that's how we're going to prove this. I'm going to find vector AB and vector DC just by subtracting the end minus the start. So for AB, I'm going to do the B values minus the A values. So 3 minus 0, -1 minus 3, and 17 minus 5. And then for DC, same idea, that D values minus, it's DC, so I do C minus D. That's careful with the order there. So 7 minus 4, -3 minus 1, and 15 minus 3. Okay, we'll also double check the other pair that I've drawn there. So I'll do AD and BC. So we're going to subtract the D points minus the A points. So 4 take away 0, 1 minus 3, and 3 minus 5. And then for BC, we'll do the C points minus the B points. So 7 minus 3, -3 minus -1, careful double negatives, and 15 minus 17. So to summarize that, we can just say, therefore, ABCD is a parallelogram. Because vector AB equals DC and AD equals BC. Okay, next one. This is a really good question, but I think I'm going to need to snag a diagram from somewhere to help me not have to draw this. I think I almost spelled it good enough. All right, so this shape, a parallelepiped, just going to put that image into here to save myself making a big mess of this drawing. Basically, it's sort of like a rectangular prism, but it's instead of rectangular sides, it's parallelogram sides. So it's like a tipped over rectangular prism, or it's like a parallelogram prism. So we've got these vectors, and we'll see that this parallelepiped starts at the origin. I'm going to draw that one as O. And we're going to talk about this in terms of these vectors, OA and OB, which we'll label as this guy here, and OC. So what we want to do is to figure out the other 4 coordinates of this parallelepiped. And I totally skipped out on the drawing of it, but I hope You guys will excuse me. This one, I'm just going to label these F and G. Doesn't really matter where you label those. Okay. So the key here is that sort of like, I'm going to see if I can highlighter these. Sort of like with the rectangular prism, we know that if these are parallelograms, that all of these corresponding edges will be the same. So I'm going to kind of highlight these and color code them, that all of these vectors would be equal, and then all of the ones going across this way would. So I'm going to say that OA is equal to BD, which is equal to CE, which is equal to GF. Okay, and then OB, that all these ones going the same direction would be the same, equals AD, which is also equal to CG and EF, all those blue ones, and then OC would be equal to AE, which is equal to BG and DF. Is everybody okay with the setup there? That all of those like pairs of, or sets of 4 edges would be the equal vectors. Okay. So I'm going to really try not to let this get too messy. If I wanted to find, let's say, point D, what I'm really looking for is vector OD. From the origin, how do you get to point D? What do you do? So I'm going to go along there, and I see that OD is OB plus BD. So OD is OB plus BD. And I know what OB is. OB is 0, 4, 1. I don't know what BD is, but I do know that BD is equal to OA. So that's kind of what I recognize from my list of all the equal vectors. So I'm going to say that OD is OB plus OA, because those two I know both of. So OB is 0, 4, 1, and OA, oh, sorry, there's a plus in between there. And OA is negative 2, 2, 5. So then you get negative 2, 6, 6. So that point there is negative 2, 6, 6. And then you're going to do the same for each of the rest of them. So to get point E, F, and G, so OE would be OA plus AE, but then you'll have to kind of look over here and say, oh, what's AE equal to that I know? And it's equal to OC. And then you'll just add up the vectors that you know that you're given. Okay, so then OG is going to be OB plus BG. You could look at that another way. You could have gone OC up to OC and then CG. There's different ways to get to these, but they'll all end up the same. I don't know what BG is, but I do see it in a list somewhere. BG is also equal to OC. So then you can use that to solve. The last one, to get from O to F, we're going to have to go kind of a lot of places. I might go OB plus BD plus DF. And then you'll have to replace two things with values from that list of equal values, of equal vectors. Does that one make sense? Yeah. Stop me if you have questions for sure. So I'll let you guys finish that one off. The next one, page 333, number 15. This one's kind of interesting. This goes back to like our geometric vectors. We have the magnitude of A, the magnitude of B, and the magnitude of A plus B. And we want to figure out what's the magnitude of A minus B. So here, if we have, let's say, vector A there and vector B there, and I know that the magnitude of A plus B is 7. So if I found vector A plus B, remember I have to like make my triangle, and there's the resultant. If I kind of redraw this triangle, what could I find here? So that's 3, and that's 5, and that's 7. So what do I not have in this question that I would need for sure to do some calculations? Oh my gosh, I'm sorry guys. I just realized I was mute. I had my volume off. I hope you haven't been talking the whole time. Yes, an angle. Sorry folks. If I missed things that people said, I kept saying unmute and I had my, oh gosh. All right. So I'm sorry. Yes, we need an angle. So I'm going to figure out this angle theta in there. So I could say that 7 squared equals 3 squared plus 5 squared minus 2 times 3 times 5 times cos theta. And if I, okay, theta is 120 degrees. It's kind of a nice exact value there. So that tells me that that angle up there is 120. If I wanted to redraw this to find A minus B, remember that I would have to go in the opposite direction. So here I've got A, and then I would need to do like minus B this way. And if I'm getting this resultant of A minus B, what angle would I have in there? You could look at this a number of different ways. Some people would take that 120 up here and get down to there being the 60 degrees. Yeah, or you could just kind of look at this as like a supplementary angle. In either case, you're going to have this angle in here is 60 degrees. So then you would have the magnitude of A minus B squared is 3 squared plus 5 squared minus 2 times 3 times 5 times cos 60. So I get that that's 19, root 19, or about 4.36 units. The next one is looking at algebraic vectors. We've got x plus y is equal to this. It's actually kind of similar, looking at kind of x plus y and x minus y. I think that this is a lot easier to see if you line them up vertically, I guess. So x plus y is negative I hat plus 2j hat plus 5k hat, and then x minus y is 3i hat plus 6j hat minus 7k hat. So here, this is lined up really nicely actually to do elimination. I'm just going to add these together and eliminate the y's. So I would get 2 times vector x. The plus vector y minus vector y is gone. So then I'd have 2i plus 8j minus 2k. And then just dividing out by 2, I would get vector x is I plus 4j minus k. And then solving from either one of these equations, x plus y is probably what I would use. Putting in the values for x and then solving for vector y. So I plus 4j minus k is our x. So plus y equals negative I plus 2j plus 5k. And then if I bring the terms from the left over to the right, I would have negative 2i, and then I have 2j minus 4j, so negative 2j, and then 5k plus k, so plus 6k. So just sort of rearranging all of the algebra that you've done all along also does work with vectors. Just checking over to the chat. Okay. This is one where we're looking at, the next one, we're looking at kind of a combination of the unit vector form and component form. So if a plus ai hat plus 5j hat equals negative 3 comma b, find the vectors of a and b. I feel like this is almost a trick question, but this is just converting into component form. So a I hat plus 5j hat would be in component form a comma 5. And if a comma 5 equals negative 3b, then just matching up the x's and the y's. So a is negative 3 and b is 5. So then we're going to do the magnitude. Which would be the square root of negative 3 squared plus 5 squared. Or root 34. I really like this one because I think it's important to recognize the difference between vectors, points, and vectors and their magnitudes, and a vector from the origin to a point, and then the vector between 2 points. So I'm going to kind of go through this, and I'm going to label the origin on here. So this is vector A, or point A, pardon me, -2, -6, and 3. And you'll notice when I'm drawing points in 3 dimensions, I never will expect you to draw like those nice 3D diagrams of multiple points to try and figure out information between them. I just kind of put them randomly on a page, and it's like a visual representation, but it doesn't actually have much to do with the math itself. Okay. So you're not going to get an accurate picture of this, but it's just nice to sort of see 3 points on a page. They could be anywhere in space. We don't really know. We don't really care visually like where they would be, but we can draw them sort of however we want, but just to show the relationships between them. So we know that vector OA is the vector from the point at the origin to point A. So vector OA is the origin, obviously 0, 0, 0. So remember the end minus the start. We don't even really typically show this because subtracting 0 doesn't do anything. So this would be -2, -6, 3. And then we're going to have a different vector OB here. Same idea. The points of B minus the points at the origin, 3 minus 0, -4 minus 0, doesn't change stuff. So that's 3, -4, 12. The one that's a little bit interesting is vector AB. Notice that this one's the one that we have to do some work for. We have to do the end minus the start. So here, 3 minus -2, it's gone 5 in the x direction. Going from -2 to 3, you went 5 steps. -4, pardon me, minus -6. That's like -4 plus 6, or 2. And 12 minus 3. In the z direction, you've gone 9 steps. So that's vector AB. So if I were to do all of these calculations, for A, the magnitude of OA is going to be the square root of -2 squared plus -6 squared plus 3 squared. So the square root of 49, which is 7. So for B, the magnitude of OB, same idea. We've got 3 squared plus -4 squared plus 12 squared. So that would be the square root of 202. So C, I already did. It's up there. Vector AB is 5, 2, 9. Those are the steps that you go from point A to get to point B. If I was looking for the magnitude of AB, remember for D there, we've got those magnitude bars. This is finding the magnitude of that vector I just did. So that would be the square root of 110. The last vector I didn't have drawn on here, but I can put it in. If you go B to A, hopefully you guys can see that that would be the negative of vector AB. So vector BA would just be -5, -2, -9. And you could always just subtract those in the opposite order, but that's really what you're doing. So for E, vector BA is -5, -2, -9. And notice here, when you've got just the vector, I'm looking for an answer usually in component form. When you have the magnitude bars, the up and down bars on either side, I'm looking for how long that vector is. So here, this one's going to be the same as the magnitude of the opposite vector. The signs don't matter because you're squaring them, so that'll be root 110 as well. Of course, the vector in one direction is the same length as the vector going the other way.